Oh, it's felt like ages since I've done one of these videos, but we're back to our normal-ish sort of schedule. I mean, it's kind of hard to call anything normal when I invert my sleep schedule every few weeks, and yeah. But anyways, we're back to working on modded stuff, and between the last videos and this, really not a huge majority has changed. Most of it's just been polishing work of trying to get mods functioning better, fixing bugs, and of course making cool commands like the one I'm staring at. Well, actually, the commands here. This is inventory code I'm messing with. But yeah, I made a command here to output recipes here. I can actually show you the byproduct of it, and next time we launch, hopefully I'll remember and I can actually show what it kind of looks like as well when it's running. It's pretty simplistic. The idea behind the command is to save time, of course. That's what pretty much most of programming ends up being related to, is trying to save as much time as possible. But this one also kind of is meant to kind of easy button everything. So the main reason I came up with making this command is I'm still in the process of converting a lot of content over to the JSON and Node system before I update the 1.8, although to be honest, I'm probably just going to start the 1.8 update one of these days and then just say fuck it to converting everything. But one of the things that needs to be converted was the explosive. Now, explosive has a lot of recipes. There's a lot of actual explosive items, and these are what are ID'd in order to insert explosives into the warheads. There's not some special process that just makes the warhead function. Literally, there's an item that goes, okay, I'm a nuclear bomb, and then you stick it into the warhead. So if you go down through here, you can see all of them, and this is all generated via command, and it's all generated, and it's reusable code, so it actually can be used for other things. Eventually, we'll get to a point where I could fire this off and I can take and generate an entire item out of JSON just via command. I can go like, for example, I want a clone of the block stone, and I can go, hey, clone me a block stone, and all I have to do is come through this file and say, for example, change the name here, for et cetera, et cetera. Now the recipes are straightforward. It auto-generates the grid because Minecraft does not save the grid for anything. It does save what you're supposed to craft with. It does not save the symbol. So if we actually go and looked at the explosive unit, for example, you'll notice the symbols here don't match at all what is in here. So we got, I don't even know what this is. I think it's a fragment of some kind. Yeah, it's an arrow fragment. So you'll notice this uses capital letters throughout the whole thing, and it also uses a G to refer to everything. And we've got arrow bundles and explosive charge. If we come over here, it does indeed use the arrow bundle and explosive charges, but they're different letters. Entirely auto-generated. It can support basically the alphabet times 2, so I believe it's 27. I may be wrong. Yeah, but it'll do capitalization and it'll do lowercase, and supposedly the system can identify both those differently. If somebody managed to use more than that number, which I believe is 54, I could be wrong. I think it's 54. Somebody managed to use more than 54 characters. I'll add support for numbers, and I'll pretty much actually add support for every ASCII character. And if they somehow go beyond that, which you should not be able to do because the fact is these crafting recipes are only loaded by 3x3s to start with. They load the standard forge recipes, and the standard forge recipes only function for 3x3. That being said, there is support for larger recipes built into Volt's engine, but you're not loading a standard recipe at that point. It's then going to let you do whatever size you want, which even then, in order to use all 54, yeah, you'd have to pretty much have 54 different items in there, which means your grid size would be about a 7x7. Pretty much, yeah, 7x7 would be that grid. And there is a mod I believe has a 9x9, so that mod would have difficulties, but Voltage is not designed for that kind of mod. If that mod actually wants to have its own 9x9 recipes, they can make their own recipe loader, which isn't too hard. It's prefabbed out really well in Voltage. But moving past this, because this is me just kind of warming up for the day, because, yeah, going to be slightly slow day, because I've still got a little bit of that cold I was talking about a few days ago on Twitter. It's still hitting me up, although I'm trying to question if it's a cold or allergies. But for today, we're going to work on something. Now, I kind of want to just work on more conversion stuff, but at the same time, I've been watching a lot of the Shoddycast videos. I got to see a couple with nuclear bombs in it, so you know what? Let's make some explosives. Now, I probably shouldn't be adding explosives this late into the cycle to update the 1.8 because it's just going to make my job harder when I go to update. But I'm bored, and I want to make something that blows up. So we have the antimatter blast, which does need to be worked on more. And we need to add a red matter, and we need to add a nuclear explosion. Now, I've already noted several times when it comes to nuclear explosion, the reason I have not added it back in is because I want to make it highly detailed. I want to replicate every aspect about the nuke. I don't want to just end up with basically a giant piece of TNT that spews radiation particles. I want to add the neutrons to it. I want to add the gamma rays. I want to add the infrared radiation, ultraviolet radiation, microwave emission, ionization of the atmosphere, because all these will stack up to make the effects much, much, much stronger and much more nicer. There's a lot of aspects to it that will be really, really useful into the game of PvP, because ionizing atmosphere, for example, will prevent radio communication from functioning in the area. This means further launches of missiles would not function. There's a lot of other aspects that we do as well. See, the infrared, for example, is going to actually do huge amounts of damage. It's going to catch things on fire. It's going to cook any entity alive that's there. It's going to blind people. Same thing with the ultraviolet, would mess you up pretty good too. Microwave is going to do a lot of stuff. Of course, you have the EMP effect, which I believe is actually made by the microwave radiation, but I have to do more research on that. But you know what? We can get started. I'm not going to make the thing craftable, but I'm going to toy with it real quick. First things first, I got to figure out which package I want to throw this in, because this is not organized. Now the plan is, when we go to set a nuke off, we're just going to literally layer a blast up. So you're going to fire an EMP blast, and then you're going to basically set off a thermic weapon of some kind. It's not going to be these two. It's going to be... There's actually a name for something that acts like a nuke, but isn't a nuke. Thermobolic, I believe. We need a few things. You know, I'm just going to get a package for it, and we're just going to go from there. So we're going to need a new blast. So we're going to need blast, nuke. And this is going to be complicated, because what we have to do is the first layer, we have to atomize the ground. Now, when a nuke goes off, it produces neutrons, which mess up everything. They hit things, they will split atoms. So you can imagine whatever you're going to hit at the impact center of that explosion is just, it's going to be gone. There's not going to be nothing left. Then you need a blast wave, heat. What else is there? Yeah, we did infrared, UV, neutrons. I actually don't have a good list of this. EMP. You know what? I'm going to probably Google something in a second. So let's do this real quick. Components of a nuke blast. There's fission, fusion, tritium. By the way, most of our nukes are going to be this design right here, which is going to be the gun design, which means you're shooting a piece of core of material through a hollow core. That's how they're going to be designed and built. I'm probably not going to do the other types right away, because this one is the World War II version. This one, I have no clue. I only know the physics behind this one. Energy dispersion of the weapon. This is useful. So thermal energy 35%, instant radiation 5%, residual radiation 10%, and then blast itself is 50%. So we're going to have to figure out some kind of value we want to use. It's got to be scalable value, because you're going to be able to put more into your warheads, which, by the way, when I made the warhead system, I didn't know that's actually how real ICBMs actually worked. So when it comes to like a nuclear missile both the US and Russia use, they can have more warheads than just one in there. I always assumed they only had one warhead and it was dispersed. It turns out they were actually designed to have 3 to 5. And although the US warheads usually only have 1 in them for cost reasons, and where the Russians, on the other hand, have 3, which, I mean, you can see what that did to their economy. They went bankrupt after a while. Okay, I'm not getting anything off this. Actually, apparently I want a nuclear explosion. This stuff is not. The sad thing is, like, you can't get good information on this. By the way, we're not going to be doing the mushroom cloud right now either, so don't expect this video to have this cool particle effect. I got to make that, and then the mushroom cloud is actually going to be part of all the explosions because this is actually not unique to nukes. Any large explosion makes a mushroom cloud. I had, you know what, actually, hold on. I think I already had this all written out. By the way, if you guys actually pay for the Patreon, you can get access to this folder. Okay, here we go. So apparently I actually detailed this all out at some point, which means I did the research at some point. So we have the center of the blast, which destroys blocks, and we have the blast itself. We have the shockwave, thermal, flash, ionizing of air, EMP, earthquake, and then radiation. This isn't going to probably happen right now. And then we will be able to do radiation probably sometime today. Ionizing air probably won't happen right now because I got to do a lot of work for that. This is pretty easy to do. This is going to be part of the thermal. No, that's actually light. Okay, so thermal is actually heat, and then we got flash, which is light, and it's going to be UV light and infrared light, which is, of course, is going to cause thermal effects on impact. So it'll catch you on fire. But then you actually have actual heat distributed by the air, which will be the thermal blast wave. I got this. Oh, there's effect from here. Cool. I make sure to keep track of my sources. Haha. It's got that same information here we saw earlier. Blast is 40%. Okay. I think this is what I based my calculations on too, is some stuff like this. So complete destruction between, okay. This is a weapon that has a 3.5 mile radius. This is the pressure wave of it. Unfortunately, I am going to have to do a lot more research. This is why I always tell you guys when I'm working, I do research on the side. I actually research into a lot of the stuff I develop. Not just this though, because actually I rarely research into explosions. It's not really my interest. Conflagration. Now there is actually an explosive in Classic that's called this. That does not do this whatsoever though. So that's basically a fireball. So we want to mimic this as best as possible. Now, I probably should have designed this before making this video. We're going to go with the numbers I have because they're easy to modify, so we'll just continue working off this. I'm going to throw this on the other screen real quick. So what we want to do is we want to scale everything to 100 meters. So our default size is 100 meters, of course. This will be for, I don't want to say 1 unit of nuclear material, because I want to be able to make mini nukes from Fallout. That's basically where this started off. I was like, you know what? Let's make a mini nuke launcher. So I want to be able to make stuff that's actually really, really small. So we're going to have to do some kind of scaling effect. But what we're going to do first is we're just going to go with the conventional. So for the moment, what we're going to do is we're going to clone antimatter, because this will get us a really quick startup on the fact that we can disintegrate the middle of the blast. Now I'm going to delete my notes here because I don't need them anymore. And this is blast nuke. Reformat this. Import class. Rename. I just got to import a whole bunch of stuff real quick because I didn't grab the imports with us. probably going to rename that config here because there's going to be a couple more explosions that are going to be able to break bedrock. This is going to be one of them. Not only will this be able to break bedrock, it'll be able to do quite a few other things. I'm probably going to implement effects on magical-based devices and entities, because the ideal is that you're producing energy. Now, you're producing all kinds of energy. This includes being destructive energy in this case. So this energy, theoretically, if magic was a real thing, could completely, utterly mess magic up. There's a few mods, I believe, that have weird magical fields and properties that would be so fun to mess with. Okay. We got a lot of work to do. So what we want to do is we have some kind of default scale factor. So our default scale factor is going to be public static int default size will be 100 meters. We then want to have the center of the blast, so public static int percent antimatter range. We're just going to call this antimatter pretty much. So it's just going to be 20 divided by that, and of course I'm going to have to do this real quick, and this is going to have to be a float. So we're going to do this float, and you know what, we'll just make this a float too while we're at it. That'll save me so much time on calculating. So this is going to end up being like 1/5. So 1/5 of the size of the explosion is how you're going to end up with, etc. We're definitely going to have to come back through here and we're going to have to make some logarithmic equations for this because I don't want the center scaling proportional to the size. So if you went up to a kilometer, you wouldn't all of a sudden get a 200-meter blast center. This would scale a lot slower compared to your max size. For the moment, it's just going to work because we just need to get some stuff working. The thermal is going to be its own blast. The flash is going to be its own blast, and the EMP is going to be its own blast. So how this is going to start is we're just going to pretty much make ourselves a clone of the antimatter bomb that has a limited range on its destructive capability. I'm trying to think of the best way to do this right now. Because what we really need is we need an energy-based blast, but I don't want to use energy-based blast code right now because TNT uses it, and from testing with the TNT, we know for a fact that it's problematic. Actually, you know what? I'm going to go ahead and launch the game while we're thinking about this, so I can just show you that there's a problem with the TNT blast. So what I did is when I created TNT, I designed it to be completely energy-based. This basically means that when it goes off, it produces energy that goes outwards and hits things, and that energy will either destroy the object or reflect off. The main bonus thing is the deflecting off because this creates highly powerful blasts, so that way if you put it against an unbreakable object, it's going to destroy more things on the other side of it than it is going to be just lose that energy. However, antimatter is a simple object, which means it doesn't do any energy blast. Kind of problematic. So this means we got to, until we get that energy-based code working, because we're going to switch to energy-based code the first chance I get it working, is that we have to decide kind of what blocks we can path and what blocks we cannot path. This means we got to calculate some kind of energy based off of distance, and then we got to decide what that ability of breakable is. We need to make sure that, I believe, the second level of concrete from military base decor can take up nuclear hit. We're not going to make it break bedrock for the moment, so what we need to do is hardness is greater than 0. Or actually, yeah, we're going to leave this how it is, actually. We're just going to move this check. So if it's unbreakable, we just ignore it. Then we want to go calculate expected energy. So I'm going to go float energy equals distance, actually be center dot distance location. So we want to get our distance to location as a value real quick. So we're going to actually do this double distance. So this is how far away we are from the thing. I'm actually probably going to start making these should path include distance as one of the passants. That way we're not recalculating every time we need it. Now this should by default actually have a few things in here. First things first is, by the way, this is a Pathfinder based object. It will only calculate so many blocks per cycle before it pauses and lets the main game loop continue doing its own thing. It's actually designed to not hinder the main game, which is going to cause us a few issues with larger blasts. This is the reason why I've also noted in a couple videos that when we get to the really big nuclear and antimatter explosion, I'm literally just going to delete a chunk. I'm going to assume anything in that chunk just died, because when you get to the really like Tazar style large bombs, there's nothing in Minecraft that's going to survive a hit from that. Not even the force fields are going to be able to take that energy, because you're literally releasing so much power, not just from the blast, because the blast wave, of course, a force field might be able to take, but it'll be the radiation, the neutrons, the pure energy release, the heat itself would collapse a force field. There's so many other factors that would collapse that force field. Ionizing effect probably would disable force fields. We may revisit that later when we finally decide what the physics behind the force field are going to be. Yeah, we'll go here. I don't know if I got a way to show you guys the larger explosions. In the earlier on, before we started doing these daily dev videos, I used to do really large test ones. We're talking about like ones that would cover everything until you could see, just to test to see how powerful our explosions are. You know what? I don't want to mess this world up, because I plan to still do more tutorial videos in that world. If I can remember, why does it take you back to the multiplayer menu? Creative bomb test. Yeah, I gotta go finish the tutorial videos here later. I'm hoping to get some editing software before I go and diving down into them. That way I can edit out background noise, I can deal with weird issues, make sure that it's full screened, and insert really nice stuff. Also deal with the fact that my computer doesn't frame rate well on Worlds. I'm planning on upgrading to a better computer here in the next couple of months. Anyways, we got a small explosion. It goes off, which, by the way, my audio is pretty low. So we got a small blast here. That one runs pretty well. You see there is some problems with corners here. This is where you can see the energy-based path calculation actually is doing something, because it's running out of energy before it hits these corners right here. And it varies depending on how it hits, what angles it hits. Of course, the fragments like to freak out when they hit sidewalls. By the way, when the nuclear blast goes off, the fragments are going to be imbued with radiation, and they're going to fly for kilometers. Needless to say, you're going to have problems. Anyways, we scale up to a little bigger one. You see it takes a bit longer for it to calculate. That's mainly actually the fragments that causes the problem. Because if we actually go down in the console here, it'll actually tell me how long it takes to run. So it takes us pretty much microseconds to run the small one, and then we start to get into milliseconds. This is actually somewhat problematic because it took us 11 milliseconds, and we only have 50 milliseconds total per tick. Now this doesn't affect anything for the reason that we are threaded, so this is 1/5 of the time we have in a thread, so it doesn't really make a difference. But that's just a small explosion. Now you can imagine there's several of these going off at a time, could possibly actually hinder that, and you could actually see where it takes several ticks before an explosion shows up in the world, although that actually is never the case because of how the larger explosions run. I need a way to actually make this larger, and the problem is I can't think of a way to do it. First, let's fix this real quick. So we want to do default size, or no, size divided by default size. This has to be a double too, I guess. So what we're doing is size divided by cell size. We're getting our scale factor. So actually we'll just separate this out the scale factor so it's a little easier to understand. And then we want some kind of modifier for distance. Okay, blast energy loss by distance. I think I did lose instead of loss. Oh shit, I hate reading these big papers. Blast rate for TNT explosion on open air, standard atmospheric pressure. Of course, we're going to assume standard atmospheric pressure because I'm not doing complicated math for you guys on this video. There's a reason I'm not an engineer. I hate doing large math. Okay, I'm back. My brother was interrupting me looking for noms and junk food. Okay, so we had a lot of formulas here, and I'm actually going to save this for reading later here so I can refresh myself on this math. I used to know how to do it because, well, taking 3 semesters of physics, you learn a lot. And this is one of the things they actually surprisingly teach you after a while. They don't spend a huge amount of time on it because it's just to teach you that energy released in the air has an effect. And this isn't actually, I believe, the equations that are used. Open air, atmospheric pressure, standard air temperature in this formula. Mass is kilograms. Of course, we're going to have problems with this because none of our stuff uses proper values. Shoot. And the formula gets more complicated as you scroll down. Basically, as the radius of the blast increases, the less the pressure is. Oh man, I can't math today. Basically, there's a volumetric thing going on here because you got radius times mass, which we would have to know what our mass equivalent of TNT is. Unfortunately, I do not have those values on hand. And then, of course, this wouldn't help us because it would give us the overpressure. So I'd be like, well, you've got 10 atmospheric pressure, and I don't know what that correlates into damage. I knew that would kill a human being if it hit it, but what would that do to a stone wall or a wooden wall? I know glass would be blown out. That's actually a big thing we got to do here later is we got to blow out windows. This means this is going to pathfind air. This is going to be a really slow calculation. The reason I say this too, and yeah. First things first, we just get this to some kind of value real quick so it'll compile and will not crash. So that way I can come down to the TNT blast, which is actually stored into the core in case nobody knew that. So we go core, world, explosives. Oh, that's lib. I need to go prefabs. Eventually I'm going to get all the explosive code separated out, so if you guys ever want to use it for your own mods, it will be available. Although you will still have to do things like download the API and probably download the coding lib. The code can't be 100% independent from my code because it'd just be too damn hard to develop. Although I am probably going to heavily simplify it here eventually. Set yield times 100. This is how I'm going to cheat real quick, and pray to God I don't release a version that actually contains this in here, or you'll wipe everything out. Okay, so I pray I don't crash on this. There's a reason I say this is there's a particular reason why there is not a large explosive in the ICBM right now. It is in the process of switching to a Pathfinder, and in the process of doing a lot of things to help improve gameplay. There is a maximum limit to how large an explosion can be due to the amount of RAM it takes to actually pathfind. I am working on fixing this, but there's This is also another reason why I'm going to flat out delete chunks with large explosions, is because I don't want to actually calculate how big that explosion is going to be, because, well, there's only like 255 meters of material anyways in a chunk, so you're going to just delete everything regardless. So you can fake things for days. Now this is actually going to take a while to run, because this is probably like a 500-meter explosion. And unfortunately, I don't have debug lines that are going to tell me what's going on. So we're just going to have to kind of wait here and figure out some way we can see the game while we continue working, because it's going to probably take it like 10 minutes to run. I actually am not lying on that. I think I have a video around here where you guys can watch the antimatter explosion go off at a size of like 1 kilometer. And I think it took it like 27 minutes to run. Now that's better than the 4 hours it took previously. I'm not lying on that either. I've heavily optimized the old code. And then you get Cal Clavi's version, which would just flat out crash. It wouldn't run because he was using... Actually, no, his was not too different than mine, except I use a Pathfinder and he didn't. He used an orbital calculator, which took up big O notation into the 3, or actually I think it was into the 4. So as your size went up, so n would be your size, you would get larger and larger. To kind of put this in perspective, if I had 1 and I put it to the power, we'll just do 2 by the way, it's going to be 1. But then as soon as you take it to 2 and you power it to 2, it goes to 4. Then you take it to do 3 to the power of 2, it's 9. Now you do this to 1,000. So if I have 1,000 iterations just on a square size, I'm 1,000,000. Now if we do this again with cubic, and I do to the power of 3, it's 1,000,000,000 now. Actually, was it? That's 1,000. Still 1,000,000. What did I screw up here? Okay, no, I think I'm right. 1,000, million. Okay, yeah, 1,000,000,000. Now you take it to the power of 4, which is what his actually was. We're at 1,000,000,000,000. So 1,000, million, billion, trillion. Now my calculations are really close to being end of the 1, which means if I have 1,000 blocks to edit, I only 1,000 blocks. Energy calculations, unfortunately, are 3, so they take you iterate 1,000,000 times. They're not quite 3. It's somewhere between 2 and 3 because it can iterate easily over a block twice, which it's not supposed to do. But you have energy reflection, which means there's no way to stop it from reflecting. There are some minimum and maximum value for energy deflection, so it does guarantee it eventually does stop iterating. But yeah, Cal Clavius had that huge problem with his because he didn't cache what blocks he iterated over. So he did not have memory issues like I do, so I have a max size because of memory. His didn't have that, but his had a problem with amount of time it took to run. Now, of course, his explosions, I think, capped out at like 100, 200 in size, so that wasn't a problem. I think we're running like a 500 right now. I hope it's a 500, because if it's any larger, then, well, we could be here all day. If it doesn't end by the time of this, I'll actually just kind of leave the recording running, and I'll clip out the part where it blows up and paste it back in. So we got our distance, we got our scale factor. Now we need to figure out what kind of energy we're going to do with. It needs to be not linear, which means we need to consider the volume of the explosion. Problematic, because this math always breaks. So we need to decide how much energy we want for starters. By default, I think the all blaster program with 5 newtons of energy per block. That's how they do their calculations on how many blocks they can blow up. I think the game just froze. Oh shit! I think we maxed out on memory. Did it just finish something? Oh, I had my hopes up. So had my hopes up. No, we just kind of ran out of stuff here. If you look up top here, we are maxing our memory out. I'm using 3 gigabytes too. If we maxed out again, the game's gonna freeze. We're probably not gonna see this go off without me increasing my memory. So we know we want 100 energy per block. So this means we want to times this by our size, or no, we want to times this by our default size, then times by scale. Now we're just going to do, yeah, actually this is going to be double d-scale, which is going to be distance divided by size. So your distance is going to be, for example, 10 meters, and your size could be like 20 meters. So this way you end up with 0.5, and you just times that by this real quick, and that gets you your energy based on that. But we're going to do this linearly because I don't have another option right now. I'm going to have to go look up the formulas for volume and a few other things to calculate what we're going to get at, and I want this video to stay under an hour. So now what we're going to say is if energy is greater than or equal to location.get get resistance. There is totally supposed to be a blame entity in here. I'm trying to remember you know what, actually I think the explosive TNT has this, so we're going to go to blast basic. Oh man. I don't think this is ever going to stop iterating because it probably just set off with the amount of energy of a nuclear bomb. Get energy cost of tile. This is actually, I think, where it's at. Or not. Oh yeah, we're looking at the wrong thing. There is now handling, by the way, for tiles that can absorb energy from blast. So if somebody wants to make like a really cool thing that if a nuke hits it, you gain power, that code is there now. That was added to actually make blast-resistant walls that damage themselves, so they can get, if they get hit, they don't just shrug it off. They actually do degrade. Oh yeah, explosion blast or explosion blame entity is what it's called over here, and something tells me it's not actually programmed in everything. I think Minecraft just froze because my video editor just froze here for a second too. You know, when this unfreezes, I'm just gonna kill Minecraft because it's not gonna finish that blast. Oh yeah, it's not even gonna let me stop it either. Yeah, it's not gonna finish. I'll do another video later with me just watching what happens when I give this thing like 16 gigabytes of RAM and let it just go at it. But for the moment, I need to get wherever this blame entity is. Okay, so the blame entity is just flat out created somewhere. Okay. So I'm going to move blame entity up a package. That way we actually have access to this for all blasts. So I wonder why we don't actually have that, because this is actually really useful information, because blocks require an entity to get the explosion resistance. And in order to trigger a block properly, you need to know the wrapper. And I don't think we've been doing that for quite a while, which has actually probably been causing a few issues. So we're going to do this, and there should be a set cause already here. This dot cause equals cause. Import class. Wrapper explosion. Okay. Gonna copy you. Gonna throw you into a few different spots, which is actually probably gonna cause a problem. I'll migrate it to its own class here later. But we want to just kind of put blast here, and then there we go. Migrate to that to an API setup later so people can recycle that code. And we want to do this real quick if cause doesn't equal null. Else. And actually, this should be created on the constructor. Yep, we'll just put this here. Because you want to keep that wrapper entity at all times because it's basically just, it wraps to your object anyways. So this is actually going to be final. No, actually not final, because I'm guaranteed at some point I'm going to come back and change that. And the last thing I want to do is be in the middle of working on code and then not being allowed to edit something. So that should give us access to the resistance value. So they'll get explosive entity to blame. Okay, so that gets me my resistance. And there's two methods for this. No, there's just one. Okay, that gives me the cause, and that gives me the location. Get resistance. Okay, there actually is a method for this already, so I'm going to make sure that this actually passes in all the right information and we don't end up with some weird stuff. So we want to make sure we're passing back the location of the blast itself, so that way it can determine how much resistance factor it wants to give back. In this case, what are we missing here? I don't think it needs a world. Yeah, you don't need a world because you're just passing back stuff. Okay, so this is going to be the location of the block we're hitting, and this is going to be the information we just passed in. So we're cool here. This is going to give back our stuff, so we're just basically going to go, yeah, cool, we can path this. And then should path. So actually, we want to, did I just close that? No, I didn't. This needs to be wrapped around here. So we basically want to say, okay, if you're outside our maximum distance of our blast, we're not going to pass. And this is going to be, actually, we just want to return this. That will probably work. It'll give us our nuke. And we return false out here. So this will let us pathfind, and this will also go, okay, hey, if its resistance is too high, just don't pathfind it. There's a few other things we have to do here, like we have to kick up shrapnel on a block being destroyed, which I think is already handled for us, but then we have to add radiation to it. Radiation will probably come later. And of course we want to do this as well, so we want to go if distance something. Actually, we want the descale, because descale will give us what we kind of already have. So if descale is greater than percent antimatter range, which is how we're just labeling it at the moment. It's not actually an antimatter effect, it's an atomization effect. Antimatter is just a fact you've literally destroyed matter and it's producing energy in the process. Your E equals mc squared type thing, I think that's how that works. I'm gonna have to do more research. This should work in theory, if not we're gonna have to debug it, but enough of our code is functional that all I have to do is then make a explosive object here, which we just copy EX antimatter. We'll just call EX nuke. And yeah, we're just going to call this a nuke. I'm not going to be inventive with this, and yeah. This will be blast nuke, and there's a few other things we're going to have to do with this and calculations. Okay, yeah, and of course we don't want it to drop any parts from the missile impact, which is what this does. But we do need to register it, so we're going to have to go into here and register it real quick. Once we register, we have to make an item for it too, or else you can't obtain it, because nothing will show up missile-wise without an item. I'll make documentation on that later. And then we have to go to the client here, and we got to add some stuff here. I got to redo how the client's handled. Right now we're basically double registering everything. Not quite double registering it, but we have two separate registry, and it's annoying, to say the least. Because this can easily be handled another way, because the only reason the client stuff exists is so we can do effects that don't mess the server up. We can do textures, because you can't do textures server-side, and a few other things. And of course, not everything has textures. For example, Nuke and Microquake are two that don't have things, although I don't think Microquake has an item. And then the next thing, we have to go to our explosive item, and we have to add an item. And I'm opening the wrong package here. Still a little foggy from having whatever this is. I want to say allergies at this point. This is, by the way, pretty easy. You just do this, add nuke, and you just name it the same thing pretty much. And we want to say scale 1 because we're going to pre-scale inside of into our nuke. How are we handling the size here? I know there's a way to do it. I'm trying to decide if I need to handle it inside of my explosive system or not. It's probably handled in the blast, which is surprising. By the way, here's our energy per thing, 5. So set yield is flat out size. Okay, so what we're gonna have to do is inside of the blast, or not the blast, the trigger code. I'm gonna remove this because I'm gonna forget to remove this in it, but we'll do, as I said, I'll do a video of that by itself. Remove this, do that. Okay, so I want this, and I want to say, okay, your default size is 100. Actually, what I want to do is default size. I want to make sure I reference this via variable so I can scale it later if I need to. Need a float, but hasn't. Really? Why is this? Oh, it's a multiplier. Cast second. Okay, that'll work. And then we just debug it at this point. It's basically what this is going to end up for the first version is just an oversized TNT blast without the energy calculations. We'll do radiation maybe in another video. And then we'll have to edit the fragmentation system. Then we're going to have to do... Actually, the first thing I'm probably going to do is infrared light. Because one of the things I want the nukes to do is if you're staring at them, they're going to blind you. It's really, really important. Then the EMP part, so how the EMP is actually going to work is there should be some code in here. I think what I can do is do affect others, and then just right at the bottom go to do trigger EMP, to do trigger heat wave, to do trigger blast wave, which by the way, almost every explosion is going to get a blast wave at some point. Anyone that actually releases pure energy is going to get one. How this will work is it'll generate a wave that goes out and it'll suck back in a couple minutes later. So it's going to have a push effect and a pull effect. It's going to mainly be designed to damage light objects like wood and windows, as well plants. There'll be a setting on it that'll be able to generate heat. So if the blast wave is hot, like really hot, it'll catch things on fire as it hits it. It's going to do most of your damage. And the reason I'm planning on doing this as well is that things like grenades and stuff need to be able to generate blast waves, because the concussion wave is one of the things that kills you if the fragments don't get you, is the concussion wave of a blast will kill you. Just to make sure this is still running with the old version. Okay, yeah, that'll do the old version. Okay, so we want to do our nuke now. By the way, after this, people cannot complain I do not have a nuke in this version. The cool thing is, the simple blast code runs amazingly fast. The downside is how the algorithm distributes the block edits. It makes it look like it's just doing a diamond formation. This is kind of how the Pathfinder runs. It's a breadth first Pathfinder, which basically means it goes along the edge and then gets the blocks one at a time. Of course, this is a 100-meter range size, so it's actually 200 in diameter, which means it's going to go out for quite a while. It's going to take a while to place. Luckily, it calculates rather quickly. The simple blast, or not simple blast, I think actually, no, it's not simple blast. It's blast basic, which is the TNT one, does take quite a while to run, unfortunately. One of the things I actually need to also start doing is prioritizing water displacement as the primary thing, like make all the water vanish before anything else. The algorithms do need a lot of work when it comes to editing things. And I do not think this kicks up fragments. I think the TNT blast is the only one that does kick up fragments. I'll have to work on this. I do need to make the energy-based blast work properly because they're going to be the ones that are going to be the most useful. And the reason I say this is right now with this blast system, bunkers don't work really well. If you leave one hole in your bunker, the hole inside of your bunker is going to be flamed. The energy-based one, however, even if you have holes in your bunker will survive. Because it actually does not turn corners really well. So if you have a lot of corners in your bunker, energy-based blasts do not function on them well. This is actually reflective in real life. It works the same way. But the simple-based, Pathfinder-based ones, one, they don't produce as nice results. We actually get these really weird cratering effects. Is it actually done? Nope, it's still gone. Memory usage isn't too bad for these, surprisingly. They work really, really well. It's the energy-based blast ones that have the maximum size on them because they just consume memory. These guys actually surprisingly get rid of memory decently well. They don't do water, which I've got to figure out a way to fix. I'm definitely going to have to prioritize water removal. The one problem with doing water removal, though, is these do not finish calculating the full size by the time they start destroying blocks. So this will start dumping blocks into the destroy queue for updating the world before it even finishes max sizing. So they are constantly ticking, they're constantly updating until it's finished. I gotta figure out some way also to make these more circular because this diamond-based blast, even though it's surprisingly not as unrealistic as you think it is, it leads to kind of a not so cool looking crater. I've got comments from like people like, oh, but these other mods have these cool looking craters. Well, they do, but they're not using a sophisticated code. Sometimes the code, even though it runs really, really well and produces nice results, does not produce visually pleasing results. It also has a lot of issues with things like gravel. I could do a 2-pass system. To be honest, what I might actually just do is tell it to hold on edits for a little bit, and that will allow me to not only fix the issue with it being diamond shaped, but it also killed off the gravel and everything. I also could just flat out just start throwing gravel around. Be like, boom, gravel gets thrown clear across the map. Some player like 50 kilometers away just gets killed by a random gravel block hitting him. That'd be just hilarious. Water's still a major issue though. But we get a blast here. I mean, it's working. It's really slow though because of the radius. I need to work on those commands to let me increase the radius would be a nice thing to do. But what I'm going to do is I'm going to call this the end of the video, and then I'm going to start up the recording here to see how long it takes a normal blast to run while I write papers for my class. Which, speaking of, I almost forgot a note here at the beginning of the video. My classes have started again. This means updates are going to be a little slower, which means videos are not going to be as often. I'm probably going to switch from doing multiple daily videos to maybe one video a day, or potentially a couple videos every other day. I'm not quite sure on how it's going to work out yet. I'm not sure how long this is going to take to run either. So I'm going to do is going to cycle the video, and I will see you guys later.